take out my iPad tonight at 8 o'clock and answer questions from 8 to 10. And I will respond back with video. So, suppose function f is continuous on a closed interval from a to b, then f of x assumes every value between f of a and f of b. Now when you read that at first, it seems like, what the heck did I just read, and did it really say anything? Let me read it again. It says a lot. Suppose the function f is continuous on the closed interval from a to b, and then f of x assumes every value between f of a and f of b. Once again, most of you read that and it feels like it says nothing, but it's nothing important to you anyways. In fact, it applies to every single person in this room and every single person that lives on planet Earth. Okay? And I'll tell you what I'm talking about. So, let's say, suppose I have a continuous function on the closed interval from a to b. So we got a and we got b. And it's a closed interval, which means the endpoints are included. And I have some function. I'm about to reveal my favorite function that I'm going to use all year long. You ready? Why do you think it's my favorite?
Pi?
Yeah, it looks like pi. Okay, so we've got closed interval, so we're only looking between a and b. The closed interval from a to b. You with me still? It says, suppose that f is continuous. What does it mean to be continuous? No what? No jumps, no holes, no VAs. That's why I say when you want to describe continuity, look for jumps, look for holes, look for VAs. If you have any, then you say those are the points of discontinuity and it's continuous everywhere else. But from A to B, do you see any jumps? Do you see any holes? Do you see any VAs? Including the endpoints. Don't forget the endpoints. Are the endpoints good? Then it's continuous on my closed interval. So we have already stated, all right, I've got a continuous function on closed interval. Then this is what it says. Then f of x, which is y, f of x is really y, assumes every value between f of a and f of b. Now let's look at f of a and f of b. Here's f of a. Here's f of b. What is it saying? What it's saying is that it hits every point, every y value in between. It can't skip over a y value. It's continuous. That's all it says, it's continuous. It can't skip a y value. Because there's no hole. I mean, if you wanted to skip a y value from f of a to f of b, you would have to have a jump, right? I don't have a jump, so I can't skip a point. If you wanted to skip a point from f of a to f of b, you'd have to have a hole. I don't have a hole. If you wanted to skip a point from f of a to f of b, you'd have to have a break, like a VA. I don't have a VA. So keep your diet straight. There's no possible way I can skip a value. Let me tell you how this applies. Every day you wake up in the morning. The low temperature this morning was negative 18. Today we might reach a high of 20-some degrees. It has to hit every temperature between negative 18 and 20. It can't skip one. You can't say, I don't like 16 degrees, I'm skipping that one. It had to go through 16 to get to 20. You were born, let's say this guy was just a huge behemoth when he was born, and he was a whole 22 inches long. Okay, that would be like a big baby. Okay, 22 inches long. How far are you now? 5'11", so he's 71 inches. So if he was 22 inches when he was born, and he's 71 inches now, did he skip 50 inches? I just don't feel like doing 50 inches. I'm skipping it. It's like old women that want to skip their year of birthday. Sorry, you didn't skip it. You might have skipped it in your mind, but you never skipped it. You're 99 now, even though you think you're 74. And you skipped 14 years, okay? It just didn't happen. You can't skip. He had to go through every height between here and 71, between 22 and 71. All right? That's all that theorem is. And it's in calculus. That's silly, isn't it? But it actually can be used to do something. So let me show you what it's used to do. Example 1, here we go. This will be exactly like your problem on the testimony. Identical, except I'll change the numbers. Apply the intermediate value theorem, which I call IVT, intermediate value theorem, to show that this function, f of x equals x cubed minus x minus 2, has a 0 between x equals 1 and x equals 2. Now, first of all, let's talk about 0. What the heck is a 0? I have told you what a 0 is at least 4 times this year. Not 7, because I need to tell you 7 before the number, but at least 4 times.
Crosses the x-axis.
Well, that only took you 4, so you're good. A 0 is where the graph crosses the x-axis. A 0, if you want to write that down, is just an x-intercept. Now, what do you know about an x-intercept besides the fact that it crosses the x-axis?
Y equals
It was on our comment. It was on our. You probably remember it from Gateway stuff when you had to find zeros of graphs. It's where f of x equals 0. You good with that? It's where y equals 0. It's on the x-intercepts where y equals 0. Now, here's what I thought. I was a punk in high school, man. I was kind of like, you know, happy a little bit. Just a punk, you know. And just kidding. That's why I said this was fun. And I would have been the guy that would have been like, why are we even doing this? Because why would I want to show that there's a 0 between x equals 1 and x equals 2 when I have the dumb equation and I could just find the 0? Well, I don't want to show that there's 1 when I could just plug 0 in for what? Like, you're probably going on your brain's like, why would I want to do this? I could just do this. Get my calculator and solve it and actually tell you what it is. So why do I want to show it? Because sometimes you can't solve the equation. Sometimes you don't have a calculator. Okay? So, a lot of times you're dealing with letters. And you don't know what the numbers are. And sometimes you need to show it without having what the equation actually is. So here's how you do it. Now I want you to think about this, and I'm going to tell you who nailed it. Michaela Sundog got this. Nailed it, got it down. Props to her. She logically figured this out. So I'm going to explain it, okay? Ready? You're trying to show that between x equals 1 and x equals 2, that this function has to cross the x-axis. So how can I, and she nailed it perfect, like the whole thing. How can I apply IVT? How can I take this theorem and take the question they're asking and show that? Before you do that, you're actually on the right track. We'll get to that. That's part 2. No, you're getting really crazy. Huh? That's what I wanted to do. I just wanted to solve it and actually find the point. But I'm telling you, you can't do that.
Check if it's continuous.
Step 1, you've got to show it's continuous. You have to say there's no holes, jumps, or vertical asymptotes. Now, look at this equation. Can you say that's continuous and why? It's a polynomial. I told you that yesterday. Since it's a polynomial, it's always continuous. So let's think that first. We got to write a paragraph proof, by the way. You have to write a paragraph. Ready? Here you go. Start writing. You're going to say f is continuous everywhere. And you don't even have to say why. You just know it. F is continuous everywhere. Therefore, you ready for your new therefore? Look at me. Therefore, we're going to see what it's there for. Okay, therefore is 3 little dots. Look at me. Here's how you do therefore. That means therefore. Isn't that cool? Canyon is just stoked right now, I know it. F is continuous everywhere. Therefore, F is continuous. You can abbreviate continuous, C-O-N-T, from 1 to 2. All right, we've done the first part of IVT. Just follow IVT. Suppose the function f is continuous on the closed interval. Have we met requirement number 1 of IVT? Okay? Then f of x must assume every value between f of a and f of b. How can I prove, using ITB, that there is a 0? All right, guys. If I plug 1 into this function, how am I going to prove, knowing what f of 1 is and what f of 2 is, how can I use it to prove that there is a 0, that it crosses the x-axis? If one of them is positive and one of them is negative, you got to cross. You can't be like the little old lady. You can't be like the lady that said, no, I don't want to do that. I don't care, I don't want to skip 0. I just want to skip it. I know 2's coming. I got to go there. You can't skip it. If it's continuous, there's no hole, no jump, no VA. I have to go through it to get there. Between 1 and 2. Same thing for the other way. If it be the other situation where it's negative, you're like, I just don't want to hit 0. I want to put 0. I can do all this craziness here. And dang it, I got to do it. Because if this one's negative and that one's positive, I don't have a choice. I have to cross 0. Does that make sense? So all I got to do now is show, okay? So it's continuous then, right? Then, so I say f is continuous everywhere because f is continuous, blah, blah, blah. Therefore, f is continuous, blah, blah. So, f of 1 equals what? Let's figure out f of 1. Plug it in. 1 minus 1 minus 2. What is it going to be? Negative 2. So f of 1 is negative 2, and f of 2 is what? 4. Good. Now here's how you write this. This is where it gets a little mechanical and a little weird, okay? So I need to take this information now, since it's continuous and since this is true, let's reason it now. So what's the reason now?
Since f is continuous from 1 to 2.
Don't we've already said that, so you don't have to include that again.
Therefore,
Okay, let's say therefore, I like that. Therefore, let's say f of 1 is positive or negative.
f of 1 must cross the x-intercept.
We'll get to that.
F of 1 is less than 2.
So we'll get to that. That's gonna be a conclusion. So since f of 1 is negative and f of 2 is positive, that's f of 1 is negative, f of 2 is positive. F must cross, like what Mason's saying, f must cross what?
The
X-axis between x equals 1 and x equals 2. And here's the punchline. You ready? Ready for the punchline? By IVT. That is the key. That pretty much right there, if you can kind of make an argument like this and you include this, that's pretty much what you're going to. They're looking for you to say this on the AP exam. You say that, you're like in heaven.
Can we just say IVT?
No, you got to reason it too.
No, I mean like.
Yeah, you can say IVT theorem. You don't have to actually write intermediate value theorem. There's two theorems on the AP exam you use. There's IVT and MVT. Mean value theorem and intermediate value theorem. I just taught you the first one. We only got one more to learn. Of our big theorems. We have two big theorems in this class. One's IVT and this one's the easy one. MVT is a little harder.
That's what the free response quiz or test really takes up.